So, ladies and gentlemen, good evening. It is a great pleasure for me to introduce our speaker today, Professor Mike Strauss. His talk will be one scientist's view of science and religion, and he will try to explain how truth is universal. Truth does not belong entirely either to science or religion. The truth we discover in one realm should always agree with the truth we discover in the other realm. It is valuable for us to have a passion for truth. He will try to show that science and religion are complementary and not antagonists. Now, a few words about Mike. Mike Strauss is a scientist with many scientific awards, with more than 1,500 scientific papers, more than 20 invited talks in science, more than 27 research grants. He is a professor of physics at the University of Oklahoma, USA, and in the same time he's a researcher at CERN, doing experiments to test mathematical theories of subatomic particles. He's a part of a highly specialized group of physicists. I think she will show something in the presentation. And he's searching through experimental data to understand what are the fundamental bricks standing at the base of our universe. He's also intrigued by the beauty and order of this universe, beyond the present understanding provided by physics, and his big question is, what is really behind it? Mike arrived from US, and we are pleased that he took his time to deliver a presentation in Bucharest, and tomorrow another one in Cluj at Babeș-Bolyai University. Before starting the lecture, we also thank the organizers, University Polytechnic of Bucharest, Raw Christian Academics, and Leaders of Tomorrow. Not to forget Nick Ripek, the man who made our meeting possible. Ladies and gentlemen, please join me in welcoming Mike Strauss.
Well, thank you very much. I'm excited to be here. Thank you for coming out. I want to thank everyone who invited me and was here. I'm going to talk for about 45 minutes, and then I'm going to let you ask questions. So if you want to ask questions, text this number, and then they will come to me. As was said in the introduction, I am a professor at the University of Oklahoma, and I do research at CERN Laboratory. The University of Oklahoma is a major research university in the United States, which means that most of my job is actually doing research, and then a small part of my job is teaching. You may or may not know anything about Oklahoma, so let me tell you a little bit about it. Oklahoma is a state right in the middle of the United States, just north of Texas, and it's primarily known for two things. The first is that the University of Oklahoma has an outstanding American football team, and unless we do really good in football, the whole state is very depressed. The other thing that Oklahoma is known for is severe weather. We have thunderstorms, we have tornadoes. In fact, this afternoon, I felt very much at home as the thunder rolled through Bucharest. My wife actually told me that last week we had 2 tornadoes that were relatively close to our house, but unless they hit your house, we don't worry about it in Oklahoma. The other thing Oklahoma is well known for that is important to you as Romanians and maybe interesting to you is that it is the home, the city of Norman, Oklahoma, where I live, is the home of a famous Romanian, Nadia Comăneci, who lives there with her husband, Bart Connor, and they run a gymnastic academy in my hometown. And so my children actually took lessons from a Romanian. I don't know if they actually had her as their teacher, but they took lessons at their academy. I do my research at CERN Laboratory, which is just outside of Geneva. It is the world's premier particle laboratory for doing research in particle physics in the world. And we want to try to understand the structure of the universe. So how do we do that? How do we understand the structure of the universe? Well, we take protons and we accelerate protons to nearly the speed of light, and we smash them together 40 million times a second. And we see what comes out when the protons smash together. So underneath the towns and villages of Switzerland and France, we build a tunnel, that has magnets in it. It's 8.6 kilometers in diameter. And inside that tunnel, we accelerate protons to the speed of light. We bend them with superconducting magnets. This is a picture of the, let's see if this works. No. All right, this is a picture of the magnets that are open. The two little pipes at the end would have protons moving in opposite directions. And then we build a big detector to smash the protons together and see what we can discover. This is a close-up of what the picture looks like. You can see people standing at the bottom and standing on the side. So this is gigantic. It's about half the size of a football pitch. And we bring protons together 40 million times a second. We smash them, and the picture that the computer takes looks something like this. And from this, we understand the structure of the universe, which I will talk a little bit about as we go on through the talk. Because I know that's why you really came, to hear about the physics of fundamental particles. So that's what we will talk about. That was a joke. It was a bad one. All right. This is my first time to Romania, and as I've walked around Bucharest, I've noticed that there are many churches in Bucharest, that Romania has a very rich tradition of Orthodox Christianity. And the churches are beautiful, and for someone from the United States, the churches are old as well. And we have you have in Romania this great tradition of Orthodox Christianity. And I look at these churches, and they are wonderful monuments, and I ask the question to myself, are these churches still relevant today? In other words, we live in a world not of huge Gothic cathedrals, but we live in a world of science. We live in a world where we build super colliders, and we send telescopes out in space to understand the universe. And we have a much better knowledge of the universe than when those cathedrals, those churches were built. And it makes me wonder, is the things that those churches stand for, this tradition of Orthodox Christianity that Romania has, is that still relevant to us today? Now, there was a time when science and Christianity seemed to go together. Some of the great scientists of old were actually Christians as well. On the bottom right is one of my favorite scientists, Michael Faraday. And these others you may recognize: Isaac Newton, James Clerk Maxwell, Boyle, and Blaise Pascal. And these were all people who made great contributions to science, but indeed were Christians as well. However, if you notice that these pictures, they aren't very modern. They're paintings of old people or black and white photographs of old people, and it still begs the question, is any of this relevant to us today? I think the relevance today comes from one of the main reasons we do science. And this was said by Linus Pauling, who was a Nobel Prize-winning scientist. He says, science is a search for truth. And as was said in the introduction, I think this is extremely valuable. We ask the question as scientists, what is true about the universe? What can we know for certain about the way the universe is put together? A search for truth. Now, there are some people who think that that kind of question is irrelevant when we talk about religion. But to me, if I'm to find truth in one realm, it better agree with truth in another realm. If something is true, then it should be true in all realms. If I learn about a certain truth about the structure of the proton, which I study, all the protons in my body obey that truth, but so do the protons in your body. The truth that is discovered is relevant for everyone if it is indeed truth. And so this is where I think we might be able to find an overlap, a consensus between science and religion. If the goal of science is to understand truth, and there is also truth in religious thought, then those two should actually coincide. They should complement each other. So what I want to do for most of tonight, and I will talk for about 45 minutes and then give you time to ask questions, is I want to talk about some of the things that science has discovered that I think actually supports those ancient beliefs, the Christian Orthodox beliefs that are represented by the churches around Bucharest. What are the things that science has found as being true that also agree with truths that religions hold dear to, particularly the Christian religion? And I want to talk about three areas: the origin of the universe, the design in the universe, and something we call the rare earth. So we'll start with the origin of the universe, and I'll tell you right off what science has learned about the origin of the universe. Through our observations of the universe, through our calculations, we've come to the conclusion that the universe appeared to have a beginning. The beginning we call it the Big Bang, and this occurred about 14 billion years ago. Now, really, the Big Bang has two different meanings. Scientists use it in two different ways, and we don't always explain that. The way it was originally proposed, it meant the very beginning of the universe, when everything started. Scientists will now say we don't know what happened at the beginning. We only know what happened about a trillionth of a second after the beginning. So many scientists will define the Big Bang not as the very beginning, but a trillionth of a second after that. Now, that doesn't seem like a very long time, but it actually is quite possible that many things happen in the first 10 to the minus 24 seconds or so. But what we seem to indicate from the Big Bang is that the universe came into existence. This is not an explosion of some kind of pre-existing gas or pre-existing matter. It is actually the origin of space and time and matter and energy. Now, prior to 1929, so if you lived 100 years ago, well, you wouldn't be living now if you did, but if you lived 100 years ago, we didn't know that the universe had a beginning. Most scientists thought the universe was eternal, it had always existed, and that it was infinite in size. But in 1929, Edwin Hubble noticed that the universe was expanding. This is a picture of raisin bread when it sits in the oven. It's full of these little raisins. And as the raisin bread gets bigger in the oven, as it cooks, all the raisins move farther apart. In a similar manner, Hubble noticed that all the galaxies in the universe were moving farther apart. And if the galaxies are moving farther apart, it means the universe is expanding. And if the universe is expanding, it means it must have started to expand. So when Hubble made this discovery, it implies that the universe had an origin, that there was a time when the universe started to expand, that it had an origin. Now, scientists did not really like the idea that the universe had an origin. 2 years after Hubble made his discovery, Arthur Eddington wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." Why is the idea that the universe had a beginning repugnant? Because if the universe had a beginning, it might have had a beginner. And to many scientists, the idea that there is a beginner to the universe is a repugnant idea. So scientists were not ready to accept this origin of the universe, the Big Bang. In fact, the Big Bang was a derogatory term coined by Fred Hoyle, who didn't believe that the universe had a beginning. He said, if I can come up with a silly, absurd name for this beginning, no one will accept the science. And so he called it the Big Bang, thinking that was such an absurd name that it would never be accepted. But scientists now believe that the universe had a beginning in something called the Big Bang. And there's 3 pieces of evidence that have convinced us of this. The first is that the universe is expanding. If the universe is expanding now, it must have started to expand. The second piece of evidence is the amount of hydrogen and helium in the universe. So the lightest elements of the periodic table, hydrogen and helium, were formed in the first 3 minutes after the origin, after the Big Bang. And we can calculate how much hydrogen and helium should be in the universe if it started with the Big Bang, and we see exactly what we expect. But maybe the most compelling evidence that the universe started in the Big Bang is the temperature of the universe. 14 billion years ago, or 13.8 billion years ago, everything we see in the universe was compressed into a very small size, and it was very hot and very dense. And over the 14 billion years, the universe has expanded and cooled down. But if it started out very, very hot, we should still see some leftover heat from that original hot Big Bang 14 billion years later, and we do. It's called the cosmic microwave background radiation. It was discovered in 1964, and the 2 people that discovered it won a Nobel Prize because it was the leftover heat from the Big Bang, the temperature of the universe. So everything we observe indicates the universe had a beginning, but it's not just the things we observe, it's also the things we can calculate. In 1915, Albert Einstein developed the general theory of relativity that describes gravity. And his theory actually predicted that the universe would be expanding, and he didn't like that idea. He knew the philosophical ramifications. So this was before Hubble made his discovery. Einstein added a term to his equation, a fudge factor, an extra term called a cosmological constant, to remove the expansion of the universe. There was no reason to do that, to add that term, except that it removed the philosophical implications of an expansion of the universe. When Hubble made his discovery, Einstein said that was the worst mistake of his professional career, to add this fake expansion term so the universe wouldn't expand. In 1973, Stephen Hawking, George Ellis, and Roger Penrose expanded Einstein's theory of relativity and understood that it actually predicted that time had a beginning. So the equations of modern physics that we can verify through experiment say that the universe had a beginning of space and time. And then in 2003, three scientists, Alan Guth, Alexander Vilenkin, and Arvind Borde, developed what we now call the BGV theorem, that any universe that is expanding on average had to have a beginning. In other words, everything about our universe points to this fact, that it actually had a beginning. And if the universe had a beginning, then you can do some logical thought about that. If the universe had a beginning, then the cause of the universe can't be a part of the universe. The cause of the universe has to be outside the universe if this universe has a beginning. So only worldviews that include a transcendent cause, a cause outside the universe, agree with science. There's one view of the universe called pantheism, that the universe itself is God. That's ruled out by science. The universe came into existence at one time. It can't be a God if it came into existence. But the biblical God, the God that is described by the Orthodox Christianity of Romania, is transcendent, completely outside the universe. And so what science has discovered is what people who believe the Bible knew all along, that the cause of the universe was outside the universe. Now, this is not just a theological idea. Scientists who don't believe in God understand the implications of a beginning of the universe. In 1978, Robert Jastrow, who is not a Christian, he's an agnostic as far as his religious faith, says this about the Big Bang: for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak, and as he pulls himself over the rock, he is greeted by a band of theologians who've been sitting there for centuries. Because the theologians have all along said the universe had a beginning, and now science has come to the conclusion that the universe has a beginning. And if you dig a little deeper, you find that not only is there kind of a rough agreement between what science has discovered, the truth of science, and what Christian religion says, but the agreement is actually much deeper. First of all, we've learned that the universe had a beginning. The very first sentence in the Bible says, "In the beginning, God created the heavens and the earth." The universe had a beginning. We just learned that the universe came into existence apparently from nothing. But we read in the Bible that the stuff of the universe did not exist at one time, that we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. But maybe the most remarkable thing is it wasn't until 1973 that we even began to discover that time itself had a beginning. Yet the New Testament, the writings of the early followers of Jesus, are the only holy writings in the whole world, the only religious writings in the whole world that talk about God acting before time. Paul writes, "Grace was given to us in Christ Jesus before the beginning of time." We as scientists didn't learn that time had a beginning until 1973. But 2,000 years ago, Paul was writing that time must have had a beginning because God was doing things before time began. So the first thing that tells us something about religion and God, maybe that science and religious views go hand in hand, is the origin of the universe. The next thing that I want to talk about is the design in the universe. And I want to focus on something called the anthropic principle. And anthropos comes from the Greek, which means humans or mankind. And the anthropic principle is the idea that the universe seems to be designed to allow humans to exist. The definitive book on this is maybe the anthropic cosmological principle that was written a long time ago now. It's actually a very good book. It's very thick, and if you really love calculus, you'll love this book. So if you love calculus, pick it up, read it at night, it'll put you to sleep. Anyway, it lists about 100 things that are finely tuned to allow humans to exist. It's as if you have a control panel that controls the universe, and these knobs control things like the strength of the strong force or the mass of the proton. And if you change the knob just a little bit one way or another, you either have no universe at all or a universe that doesn't support life. Here is what I study. One of the things I've studied for 30 years is the strong force. This is the force that holds the neutrons and protons together. So this will be on the quiz at the end, so take good notes. The universe is made of atoms, and atoms have at their center a nucleus. Nuclei are made of neutrons and protons are made of quarks. And the strong force holds quarks together in the neutrons and protons, and then holds the neutrons and protons together in the nucleus. It is because of the strength of the strong force, the knob that controls the strength, that we have the periodic table. So if you love chemistry, you can blame the strong force. Or if you hate chemistry, you can blame the strong force. Now, suppose I was to take the knob that controls the strength of the strong force, and I was to make it 2% stronger, just 2% stronger, then the periodic table would no longer have hydrogen in it. Well, that would be a problem. Water is H2O. There'd be no water. Our sun burns hydrogen for fuel. There'd be no stars like our sun. And so we wouldn't have any universe that was hospitable to life. Suppose I was to take the knob that controls the strong force and make it 5% weaker. Then I'd only have hydrogen. This would be the periodic table. Chemistry class would be easy. We'd all sign up for chemistry. But there would be no life at all. Another thing that's finely tuned is how carbon is made. So after the Big Bang in the first 3 minutes, only hydrogen and helium were created. Carbon is made much later. Stars have a life cycle like everything in the universe. Stars are born, they live for a while, and then they die. And one of the things that happens when stars die is they make all the elements up to iron of the periodic table. So the oxygen in our atmosphere, the silicon on our beaches that makes our computer chips, the carbon in our bodies is all a result of a process as stars die. I like this because poetically then we're all made of stardust. We're all made of the burnt out material from dying stars. But the process of making carbon when stars die is extremely complex. It is very, very difficult. It's very complex. There are a bunch of things we call nuclear resonance states. I once tried to explain nuclear resonance states in a talk like this, and everyone went to sleep. So I no longer do that. But it's very hard to make carbon. How that is done is difficult and has been studied. Dean Lee, a physicist at North Carolina State, writes this. We find that more than a 2 or 3% change in the light quark mass. So let me explain what that means. Inside every proton are 3 quarks, called up and down quarks, and they have a very small mass. They are the light quarks. So the things that make up a proton, what he's saying is if you change the mass of the things that make up every proton in your body, every neutron in your body, if you change their mass by 2 or 3%, then that would lead to problems with either the abundance of carbon or oxygen in the universe. We want to be here. You change the mass of the quarks by 2 or 3%, and we're not here. Another thing that's finely tuned is the entropy of the universe. The entropy is very roughly, entropy is a measure of order or disorder. The higher the entropy, the more disordered things are. When you go to your room and everything is put in exactly the right place, that's a very low state of entropy. And after a time, when all the dishes are all over the place and everything's dirty, you're at a high state of entropy. Roger Penrose has calculated that the initial entropy of the universe was finely tuned to 1 part in 10 to the 10th to the 123rd. In other words, the Big Bang wasn't some chaotic explosion. It is a finely tuned, ordered beginning of our universe, finely tuned to 1 part in 10 to the 10th to the 123rd, which is quite remarkable. So there's hundreds of parameters like this. I've listed 3, the strong nuclear force, the formation of carbon, and the entropy at the beginning of our universe. And scientists are amazed by this. They make statements like this. If we modify the value of one of the fundamental constants, if we turn one of those knobs, something invariably goes wrong. leading to a universe that is inhospitable to life as we know it. When we adjust a second constant in an attempt to fix the problems, the result generally is to create 3 new problems for everyone that we solve. The conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. And this has been done with computer programs. We change one knob and say, well, can we adjust the other ones and fix it? The answer is no. When you start messing with the parameters of the universe, you create a universe that is inhospitable to life. The third thing I'm going to talk about is the rare earth, and the question I want to try to answer is what's required to have a planet that can support higher life forms. Now, by higher life forms, I don't mean humans. I mean anything more complicated than bacteria. Bacteria can thrive everywhere. Extremophiles thrive everywhere. But once you get more complicated, it's very challenging. Now, we know there's life all over the universe because we watch Star Wars and Star Trek, and we know that no matter where we go, there's life like us. But the real question is, how probable is that? So let's take a trip through our universe and find out what it takes, some of the things it takes, to have a planet that can support life. First, you have to live in a spiral galaxy. This is what our galaxy, the Milky Way, would look like if we could get far enough from it. And the things that look like spiral clouds are the stars that spiral around the center. We have about 200 billion stars in our galaxy. Now, you have to live in a spiral galaxy in order to have a planet like the Earth. Only about 10% of the galaxies are spirals. The rest are irregular galaxies and elliptical galaxies. And they have problems with the amount of star formation in the galaxy. They have problems with the amount of radiation in the galaxy. So you have to be in a spiral galaxy if you want a planet like the Earth. And you can't be anywhere in the spiral galaxy. If you get too near the middle, there's too much radiation. Right at the center, there's a black hole, which is a terrible place to live unless you're in the movie Interstellar. And then outside, at the far end of the galaxy, there isn't enough star formation to create oxygen and carbon and things like that. So from about 1/3 of the way out to about 2/3 of the way out is called the galactic habitable zone. It's the only part of the galaxy where you can have life, like us. And our sun, of course, is right in the exact place in the galaxy where you need it to have a planet like ours. Our sun is a very interesting star. It's called a class G star. It's one of the few stars that burns long enough and stable enough to have a planet like the Earth. It's a bachelor star, which means it doesn't orbit other stars. Many stars are binary stars. They orbit each other, and the gravity from one star would perturb the planetary orbits of the other star from the other stars. So you can't have a planet like the Earth in a binary system. Our sun is also a 3rd-generation star, which is important. The 1st-generation stars that were made right after the Big Bang were made of hydrogen and helium. They had no planets like the Earth. They died. They created some carbon and oxygen, but not enough to make a planet like the Earth. The 2nd-generation stars, some of them formed and died, and the debris, the leftover stuff from the death of those 2nd-generation stars, coalesced into our planetary system, our sun. In other words, if you started with the Big Bang and you wanted to make a planet like the Earth, you have to go through 3 generations of stars to get to it. And that takes about 9 billion years, which is when our sun and our planets formed, about 9 billion years after the Big Bang. So this is the soonest, the quickest, if you start with the Big Bang, the quickest that you can have a planet like the Earth is 9 billion years, and that's when our Earth formed. The Earth is amazing. We know of no other planets like it. There are hundreds of parameters that make the Earth suitable for life. It's the axis, it's tilted at a 23-degree axis approximately, and that's stabilized by our moon. The rate that it rotates, it doesn't rotate too fast or too slow, it's just the right size. Even tectonic activity, you know, as the crust of the Earth moves, it causes earthquakes. We call that tectonic activity. It turns out that tectonic activity is actually necessary for a planet like the Earth. If we did not have tectonic activity, the water on the Earth would have evaporated by now, and we wouldn't be here. So if you want to ask, why does God allow earthquakes? Without earthquakes, we aren't here. Without earthquakes, we don't have the kind of tectonic activity that allows us to exist. And so earthquakes are actually a blessing. We need to build to protect ourselves from what the damage they can do, but without them, we wouldn't be here. The moon plays a role. It stabilizes the tilt of the Earth. Jupiter plays a role. Jupiter is this huge planet that has such a strong gravitational field that it attracts comets and asteroids and they smash into Jupiter instead of smashing into us. It actually acts as a shield to protect us. It's be very hard to make a planet like the Earth. Peter Ward and Donald Brownlee, two University of Washington scientists, wrote this in their book. If some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden. In other words, if some godlike being wanted to make a planet like the Earth, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. It is a very unique planet. It is not a regular planet. We have not found a planet like the Earth at all. We'll talk about that a little bit as we go on. So what has modern scientific discoveries taught us? Fred Hoyle writes, a common sense interpretation of the facts. I like that. I like facts. They are how we understand the universe. And how do we interpret them? A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Fred Hoyle doesn't believe in God, but he says that it seems like there's a super intellect who's monkeyed with everything and that there are no blind forces worth speaking about because of what he sees in the universe. Let me tell you the story of Anthony Flew. Anthony Flew was an atheist. He spent his entire life defending atheism. He was one of the biggest proponents of atheism. And at the age of 81, he changed his mind. For 81 years saying that there is no God, he finally looked at the evidence, this kind of evidence I've presented tonight, and he changed his mind. He never became a part of a particular religion, but he did believe there was a God. Can you imagine spending your whole life defending a point of view, and when you're 81 saying I was wrong my whole life because the facts show that? He says, I now believe that the universe was brought into existence by an infinite intelligence. I believe that this universe's intricate laws manifest what scientists have called the mind of God. This is the world picture as I see it that has emerged from modern science. Now, let me kind of review what I've said before I go to some of the last parts of my talk. What I've said is that beginning in the 1930s, scientists have discovered many things that seem to agree between the facts of science and the religious concept of God. That there was a Big Bang origin, which means there's a transcendent cause. That the universe appears designed for humans, and that the habitable Earth seems rare, if not unique. I've been talking about these kinds of things in lectures like this for about 25 years, actually. And as I've done that, there keeps being more and more discoveries. There keeps being more and more things that increase this evidence. A good hypothesis, the more you learn, the stronger the evidence. And this has been the case over the years as I've discussed this. But there are alternatives to the view. There are alternatives to the view that maybe these things all give evidence for some kind of God. And many scientists have written about those alternatives. They're proposals that attempt to avoid a beginning of the universe, the need for a deity, or challenge the concept of fine-tuning. And if you've followed this kind of discussion for any length of time, you know about these writings and these alternatives. So for me, we started off with the fact that I want to know the truth. I want to know the truth in science. I want to know the truth about religious thought. And if you want to know the truth, you have to read alternative views. So I've been reading all of these books that supposedly offer alternatives to the idea that there might be some kind of God. And what I'd like to do very briefly near the end now is go through some of these alternative views, because you may have heard about them, and say, do they really contradict, do they really destroy any concept of God from these things? So let me just go through a few of these. We'll talk with some alternatives to the rare Earth hypothesis, the idea that the Earth is unique. One of the things you hear is that there are a lot of planets, so we should find ones like the Earth. And the other thing that's often said is, well, maybe there are other forms of life. The response to this is twofold. What is an Earth-like planet? How easy is it to make a planet like the Earth? And can life be based on anything other than carbon? So we can do, as in scientists, what we call a back-of-the-envelope calculation. What would it take to make a planet like the Earth? By the way, when you read in the online or in the news that they found a planet like the Earth, they don't mean they found a planet like the Earth. They're lying. When you read that they found a planet like the Earth, they mean one of three things. Either the planet is rocky, made of rocks and not gaseous. Well, Mercury is made of rocks and not gas. It's not like the Earth. Or the planet is about the same size of the Earth as the Earth. Well, Venus is the same size as the Earth. It's not like the Earth. Or the planet is circling around a star in a region where the planet might have liquid water. Well, Mars circles around our star in a region that might have liquid water. In fact, we have not found any planets closely resembling the Earth, despite what you may have read. So we can do a quick calculation as to how easy is it to find a planet like the Earth. It has to be in a spiral galaxy. That's a 10% probability. I would normally have to describe probabilities and statistics, but you guys are polytechnical students, so you all get that, right? You have to be the right distance from the star. That's a 20% probability. Look at the bottom one. You need tectonic activity. We don't know how many planets have tectonic activity, so we just take a guess. We know none of them in our solar system have tectonic activity like what's necessary, so maybe that's a 5% probability. This is a partial list of all the things needed to make a planet like the Earth. This is a more complete list, right? And this list keeps growing. This was made some years ago, but I don't have the patience to update it. So this is an old list, and in this list there are 322 parameters that are necessary for a planet like the Earth. And when you do the math, including the fact that there are at least 10 to the 22 planets in the visible universe. So I'm only talking about the universe we can see. The universe probably goes farther than that, but we can't see it, so I'm talking about what we can see. The probability of finding one planet like the Earth is 1 part in 10 to the 282. Right? There's probably no other planets that can support life on the Earth. So when you say there are many planets, so there must be a lot like the Earth, that's just not true. It's unlikely that there's any other planets like the Earth that can support life. A back-of-the-envelope calculation supports that, so it seems to be that our planet is somehow special. What about other forms of life? Again, this is one of my favorite old TV shows, and here is the silicon-based Horta creature on the ground, right? And the question is, could we have life other than carbon? Maybe the parameters aren't so difficult to create life. The problem is, in order to create life, you have to be able to store the information of life. The information for life for us is stored in long carbon chains, and carbon can make long chains. There's no other atoms that can make long chains. Silicon has been proposed, but silicon doesn't react in the right way. In fact, in one article that tried to describe whether or not silicon can make life, the author said this: carbon chemistry is the chemistry of life, silicon chemistry is the chemistry of rocks. Right? And this is the issue. There is no other possibility for life in this universe. So we know what the parameters for life have to look like. It has to be carbon-based, and therefore the parameters are very tight. What about the origin of the universe? What are some alternatives to some kind of deity? There's primarily two. Either there was no beginning, or the beginning was caused by the laws of physics. The first one, there was no beginning, has so many refutations. First of all the observations show there was a beginning. Any alternative is not based on science. It's not based on observation, it's speculative. And not only that, but any alternative says the things we do know, like the BGV theorem, that any universe that's expanding has to have a beginning. The proposal is, well, somehow those things we do know don't work anymore. When you get to the beginning, they don't work. So it really is an appeal to gaps in our knowledge. We don't know what happened in the first 10 to the minus 20 seconds of the universe, so maybe something happened there that negates the idea we need a God. I call it atheism of the gaps. Since everything we see looks like there's a God, and if I want to be an atheist, I have to fill in atheism in gaps in my knowledge. None of them solve the entropy problem almost. None of them solve the BGV problem. And then what about the laws of physics being eternal? Well, laws are descriptive and not prescriptive. We'll talk about that. This is what Alexander Vilenkin said about his theorem, the BGV theorem. He says, with the proof now in place, we've proven it. Cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. The universe had a beginning. What about the laws themselves? Stephen Hawking has a great quote on that. He said, even if there's one possible unified theory, it's just a set of rules and equations. I can describe the universe. That doesn't make a universe. And Hawking puts it this way: what is it that breathes fire into the equations and makes a universe? for them to describe. The usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? And Vilenkin, again, about the laws of the universe, says this: the description of the creation of the universe from nothing is given in terms of the laws of physics. Some people think the universe came from nothing, but it's based on the laws of physics. That makes you wonder, where are these laws? If the laws describe the creation of the universe, that suggests they existed prior to the universe. The question that nobody has any idea how to address is where these laws came from and why these laws in particular. Yeah, I would disagree with him. I think there are some of us who have some idea of where the laws came from, but they're not within his worldview. So finally, what about the last idea, that the universe is fine-tuned? What are some alternatives? Well, there's really two that keep coming up. One is that there are many universes, and we happen to live in one that can support life. If there is an infinite number of universes, just like there's a bunch of planets, then maybe one can support life, and we just happen to be in it. And then others say, well, the fine-tuning is an illusion. There's no fine-tuning. The short response to both these is that, first of all, there's no evidence that there is a multiverse, and there are so many different multiverse models, many of them still require fine-tuning. And then the idea that that there is no fine-tuning, the answer to that is fine-tuning is really based on science. So let me just talk about these two very quickly a little bit. Suppose we did discover that there's a multiverse. Would that affect this evidence for God, and would that solve the fine-tuning problem? And I think the real answer is we don't know. There are so many models of what a multiverse might look like that the only way we can say what it would show us is if we actually found a multiverse and could make a mathematical model. But no matter what model, only a few of the universes could actually support life. In certain multiverse models, none of the other universes would be able to support life anyway, so they're irrelevant for this question. The laws of physics might require a multiverse. If string theory is a correct model of the universe, you may have heard of that, then maybe it takes 10 to the 500 universes to actually make one that can support life. So if we find a multiverse, it might actually support the design argument. So it may actually strengthen the case for God. And then kind of a philosophical question: how many universes would an infinite God make in the first place? Just one? Maybe not. So a multiverse, I don't know the ramifications. I don't think it threatens any of these ideas. And only if we ever find a multiverse and know what kind of multiverse it is can we really make some definitive statements. Finally, is the fine-tuning real, or is it just our imagination? Here's what Luke Barnes and Grant Lewis write in their book, A Fortunate Universe. They write, this reaction against fine-tuning, people who don't believe in fine-tuning, it might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field of fine-tuning began in physics journals and remains with physicists. The reason we have all these 322 parameters, the reason we know about fine-tuning is because it's been discovered and written up in physics journals. They go on to say this: while there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. So here we have a bunch of data. We have data from the origin of the universe. We have data from the fine-tuning, the design of the universe. We have data from the uniqueness of our planet Earth. And you have to ask yourself, what is the best explanation for all of the data? And in my opinion, it is this: that there is a transcendent, intelligent designer and creator who has a purpose for humanity. And that looks a lot like what the religious ideas are about where the universe came from and about the place of humanity. Now, you might look at that last sentence and say, why do you say there's a purpose for humanity? One of the reasons is that we have the rare earth. But Paul Davies makes a very insightful statement. Paul Davies, again, is a scientist who doesn't believe in God. He's agnostic, but he writes this: if physics is the product of design, the universe must have a purpose. And the evidence of modern physics, get that? The evidence of modern physics suggests strongly to me that the purpose includes us. This is a remarkable statement. Humans are not insignificant. Science itself, modern physics, according to the scientists, gives us the idea that the universe has a purpose and that the purpose includes us. Now again, if I was to say, if I find truth in science and there's truth in religion, they should agree, and this truth agrees. Some 3,000 years ago, King David had the same thought about the place of humans and how it is that the purpose of the universe could include us. He says, when I consider the heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you're mindful of him, the Son of Man that you care for him? How is it in this vast universe that humans seem to have a place? Now, there are certain scientists who have looked at this evidence and have decided that the truth we find in science agrees so well with the truth we find in religion, particularly Christianity, that the religion must be true and they have become Christians. Alan Sandage is one such person. He wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence." George Greenstein, an astrophysicist, looks at this kind of evidence and says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency with a capital A, some deity, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Now, I don't think you can prove God from science. George Greenstein speaks more strongly than I do. But I do think that the evidence, the discoveries of science can be boiled down to this. They give support. They give us support to the idea that there is a transcendent, intelligent designer who created the universe and has a purpose for humanity. And this is in agreement with what the many Orthodox churches, Protestant churches throughout Romania believe, that this describes the God of the Bible. Now, in closing, sometimes when I give this talk, people will ask me to elaborate a little further. And there's two questions that often come up. Well, then why do you believe in a personal God other than some of the things about the uniqueness of the earth? And there are really a few reasons. The design in the universe implies an intelligent mind. An intelligent mind is ascribed to personality. The universe seems to be designed for personal humans. So that seems to indicate that there is some kind of personal God. Humans have a sense of purpose, destiny, and morality. I'm made of atoms. My atoms don't have any sense of morality. They don't have any desire for purpose or for destiny. But somehow when you put the atoms together, only in humans, not in any other creature on the earth, we have a sense of morality and purpose and destiny. And those are attributes of personality, as if there's a personal God. A personal God, I think, best answers the big questions of life in a logical and consistent way. And then one other question that takes it even a step farther, well, why Christianity? There's other ideas of a personal God. And the reason is, I'm a scientist. I want to think. I want to ask tough questions. I want to find the truth. And this is what Christianity is about. Jesus says that the greatest thing we can do is love God with our heart, soul, strength, and mind. It's one of the few religions that says, think about what you believe. Ask the tough questions. If it's not true, don't believe it. It's ridiculous. Paul writes that. He tells his followers of Jesus, if it's not true, then we shouldn't be here. And so it asks us to think and use our minds. It claims to be the source of truth. We've been talking about truth. Jesus said that he is the truth. And so if I find that the claims of Jesus are true, I found truth. I think Jesus validated those claims when he rose from the dead, and that's a historic event. You can go look up historic events. Was Romania, unfortunately, under Soviet rule for many years? That's a historical event. You can go look it up and find it out. You can go look up and see whether or not there is evidence that Jesus rose from the dead. It's not just a myth. If it's not true, then Christianity is not true. So we can investigate it. I love things I can investigate and find out if they're true or not. And finally, it ultimately offers a meaningful relationship. We are all looking for purpose, destiny, meaning in life. And the message of Christianity is that meaning is found in a relationship with Jesus. And again, these are the reasons why I go from just the scientific evidence for religious beliefs to some of the more personal ones. Let me see. Let's do a couple things. I've written a book on how science and Christianity go together. It's here. I have a blog and some other things. But why don't we move to questions? So if you have questions, text this number, and we will answer some for a few minutes. Thank you for your attention.
Strauss, for this wonderful talk. As soon as I have the questions, I will share some of the information, some of the questions with you. But before we start, you at the end, you mentioned that the universe has a purpose for humanity. What can you explain more about?
Well, so I don't know that Paul Davies, who made that quote, explains what he thinks the purpose is. He just looks at the evidence from science and says the universe seems so well tailored for human existence that we must be part of the purpose, but he doesn't explain what that is. So I get that from other areas, and I ultimately think that the most satisfaction in life, the most fulfillment in life, the most peace in life comes from a personal relationship with God. And so to me, the purpose of us in the universe is to have a relationship with God and share that with others.
We have the first question, and the first question is, how do we reconcile the Big Bang Theory with the young Earth theory, especially if we say that we find truth in both science and religion? So,
right.
You can explain.
Yeah, so the Bible gives a story about creation in the first chapter of Genesis, and in that chapter, the formation of Earth, the forming and filling of Earth, is done over 6 days. And the question is, how can you reconcile a creation that takes 6 days with a Big Bang that's 14 billion years ago? This is actually described in my book. It's one of the reasons I wrote it, so Christians can understand this. But the short answer is that the Hebrew word that we translate day is the word yom. And the Hebrew word that we translate day, I don't know how it's translated in Romanian, has many meanings. Just like in English, the word day can mean many things. If I say, in the day of Abraham Lincoln, the U.S. had a civil war, the day of Abraham Lincoln means a period of time. In Oklahoma, we say it's a beautiful day, and we mean right now because we had a thunderstorm 10 minutes ago. And so the word day has many meanings depending on the context. When I read scholars who understand ancient Hebrew, which Genesis, the first book of the Bible, was written in, they will say that within the context of the ancient Hebrew, it's clear that the word yom does not mean 24 hours. I can quote scholars that say it does not mean 24 hours within the context. And so what I think is each day of creation in the story of creation is an epic, an era, a long period of time. Ancient Hebrew has only 3,000 words. It does not have a word that we would translate age or epic or era. If the writer wanted to say that God created in 6 periods of time, the word he would use is yom. That's the only word that he has to use. And so if the writer wanted to say God created over 6 periods of time, and each of those periods of time was billions of years, he would use the word yom. And so I think it perfectly agrees with the Bible when you understand that the days of creation are not 24 hours. And again, there's a lot more explanation in my book on why I believe that. I'm not trying to sell books. I'll come and give you all the details for free, but yeah.
Many questions. So we'll have like 20 minutes of question and answer. So
pick the most important ones.
Just keep coming. So how do earthquakes prevent water from evaporating?
Yeah, I mean, in the book Rare Earth, I would recommend that book. Brown and Ward and Brownlee give a whole chapter on that. But basically, it keeps minerals and all moving. It keeps things moving. If you have stagnation, it evaporates away, basically. But there are other things, and they give a whole lot of details in their book. I think in one of my slides where I talk about it, I wrote all the details because I knew I wouldn't remember them all. So give me just a second. So, hold on. Yes. So here's what I wrote from their book. Tectonic activity drives biodiversity, recycles chemicals acting like CO2. It keeps the temperature uniform basically by grabbing up CO2 and moving it around, and it forms the continents. So the primary thing is it helps moderate the temperature of the Earth. And without that, the temperature, well, what happens to Venus, right? Venus is extremely hot with an extremely thick atmosphere, and that's what the kind of thing you get without tectonic activity.
So you mentioned a lot that the universe is 13.8 billion.
Yes.
What's your take on the mature universe theory?
I'm not sure I know what the mature universe theory is. There is a theory, again, by some Christians that God created a universe that looks old but isn't old, and that may be a mature universe. Is that okay? So, so that's a possibility. It's possible we were all created 5 minutes ago with memories, and that there has been no history of the universe. But the Bible says that there's two real answers to that question. The Bible says that God does not lie. So if God made a universe that looks old, but it's not old, that would seem like a deception. The first people to begin to understand that our world was millions of years old were geologists in the 18th century within a Christian environment. And what they came to the quick conclusion when they began to understand that geology pointed to an Earth that was at least millions of years old, in a Christian environment, they realized that if the Earth looks millions of years old, it is because God wouldn't lie. But the other thing is, the Earth doesn't just look mature, it looks like it has a history. So let me give you an example. Suppose you see a tree there. Well, that looks mature. But if you look closely at the tree, maybe it has a scar where it looks like lightning hit it, or it has a hole where it looks like a woodpecker pecked at it, or it has growth rings that are different sizes, as if there's cool and warm seasons. It looks like it has a history. The universe doesn't just look old, it looks like it has a history. And again, would God make up a history that's not real? And so the fact that the universe looks like it has a history, like when we look far in outer space, we see the early universe. Light takes time to reach us. So the farther out we look, the older we look in the universe, and it's different than it is now. The universe has changed over time. And so it's certainly possible that God made a mature universe that looked old, but it doesn't align with what we know, what we can see in the universe, that it has a history, and I don't think it aligns with the character of God as described in the Bible.
Does God intervene in the creation of man, or it was a product of evolution?
So I have a little problem with the question. Christians like to pose a dichotomy. Did God create, or did evolution occur? I think as a scientist, there's lots of problems with evolution. I could go into that. But the question that I would rather pose is not, did God create or did evolution occur? The question is, how does God create? So all of you were created through a natural process. Come talk to me about that if you're not sure how that happened. But all of you are created through a natural process, yet the Bible would say God is involved. So just because it's a natural process doesn't take God out of the picture. The Bible says God feeds the lions. Well, how does God feed the lions? I've watched the Nature Channel. He gives them an instinct to hunt. So when we describe how nature works, it doesn't remove God from the picture. If God wanted to create through evolution, he could. If he wanted to create by snapping his fingers and making everything mature, he could. So the question is not evolution or creation. The question is, how did God do it? And then the Bible gives us some hints, and science gives us some hints, and I could go into lots of detail. I should say that Christians fall into, these so far have been all Christian questions, not science questions. So Christians primarily fall into three categories. One is called young earth creationists, who believe the earth is 6,000 to 10,000 years old, and both evolution and the Big Bang are not true. One group of Christians we call old earth creationists. They believe the Big Bang occurred 14 billion years ago. That's how God created the universe. But they struggle with the science of evolution. They don't think God used evolution to create humans. And then there are other Christians we call evolutionary creationists. They believe God used the Big Bang and evolution to create humans. And let's say roughly Christians fall equally into those three groups. A third are young earth creationists, a third are old earth creationists, and a third are evolutionary creationists. What does that tell you? tells you that 2/3 of us are wrong, right? And I don't know which 2/3 are wrong. And I have some ideas, but, they're all ways that God creates. In the same way God created your physical body, if you believe in a God, through a natural process, he creates through many different ways. Jesus turned water into wine. That was a supernatural creation of wine. But the Old Testament says God makes wine. So how does God make wine? He lets grapes ferment. Either way, he's involved. God is involved in thunderstorms when they happen because of high and low pressure. And God is involved in thunderstorms when Jesus miraculously calms the wind. Either way, he's involved. So I have my ideas about evolution and whether or not God used it to create humans, but it's kind of irrelevant. The question is, how did God do it, not did God do it?
How do you relate as a scientist to the claims of Christianity regarding the supernatural and miracles?
Yeah, so I believe that if there is a God who created the universe, then that same God can certainly do miracles within the universe. That would be very trivial. If you've ever read the book Flatland, which is written by Edwin Abbott, it's about a world that is two-dimensional flat, like a piece of paper, and then a three-dimensional being can easily do miracles. And I can do things in the two-dimensional world that look like a miracle to the two-dimensional being. So if there's a transcendent God, miracles are trivial. Once you've established God exists, then God can occasionally intervene in the universe. He doesn't do it that often. If God did miracles all the time with the universe, we couldn't study it, because I wouldn't know that the collisions at CERN are supernatural or natural. The reason I can study the universe is it almost always works by natural law, but the natural lawgiver can occasionally change it. Any of you computer programmers, computer science majors, right? You build back doors to your program, so you have ways to access them that nobody else can. So everybody else is using the normal laws of the program, and you as the creator know how to get around those. Right? So is that so hard for the creator of the universe if you can do it in your own programs?
Regarding the shape of the universe, if the shape of the universe is flat, doesn't make a lot of points useless, so the implications being universe is infinite, so the probability for being another Earth is also infinite.
So we don't know the shape of the universe. There are three possibilities: open, closed, and flat. It appears to be very flat. If it's flat, then it's infinite in size. So that's why I'm very careful in what I talk about. I've always talked about the visible universe, what we can see. Yes, if the universe is infinite in size, then infinite possibilities can happen. And that may be correct. That may be the best answer. It's like the multiverse. It means there's a lot more out there, and somehow we just happen to be in the right place at the right time. It's a possibility. But we don't know that it's flat. If it's closed, then it is finite. And we don't know the ramifications of a flat universe either. I like to say this. We as humans tend to make decisions not based on possibilities, but probabilities. I've driven through the streets of Bucharest. I haven't driven. I don't think I'd want to drive. I've ridden through the streets of Bucharest, and it's a pretty good possibility that you might get hit, I think. But the probability is low enough that you all are still driving. And so we live our lives based on probabilities, and all I can do is calculate the probabilities of what I can see in the universe, and that's what I've done. Yes, there are other options. There are always other options. But the question is, how probable are those other options?
There's this question: are you informed with
tachyons? Yes.
Yeah. Can you explain us briefly about it?
Yeah, I can. Do they want me to, or is that just can you explain? Yeah, so tachyons are particles that always move faster than the speed of light. So what we know about special relativity is that any object that is moving slower than the speed of light can never get to equal the speed of light. It would take an infinite amount of energy. It's the same if you go the other way. Any particle that's already moving faster than the speed of light can never slow down to actually equal the speed of light. And tachyons are proposed particles that always go faster than the speed of light. And there's no evidence for them. They're possible within certain theories. I don't know how we discover them, but I think they've been looked for. I haven't looked for them personally.
Why humans need to look for truth? You mentioned this a lot tonight. If you are just part of the truth, how would you act if you know everything?
That would be, I don't know if that's frightening if you know everything. I mean, again, my personality, my goal is to take as much information as I can and sift through it and ask what's most likely true through this information. You know, people say, well, maybe Christianity works for you. I don't know if it worked for me. To be honest, whether or not it works is not that important to me. If it works for me, but it's not true, then I'm believing a lie, and I really don't want to follow a lie. If it's true, it should probably work. But if it works, it doesn't mean it's true. And so I'm going to read people I agree with. I'm going to read Richard Dawkins and Victor Stenger and Stephen Hawking, people I don't agree with, and I'm going to see why they believe what they believe. And I'm going to try to look through the information and say, what fits the universe I see best? Why is it that we have enough food to feed the world, but we don't? What is it about human nature that's like that? What is it about human nature that makes somebody attack a sovereign country next to them for no apparent reason? What is it about human nature that does the things I see in the world? What's the best answer given all the information I have? And one of the reasons I'm a Christian is because I believe Jesus rose from the dead, but the other is that I believe it best answers these questions. It doesn't answer everything perfectly, but as a whole, it answers best the big questions of life and the little questions of life. It explains the origin of the universe and the design of the universe. It explains the historical resurrection of Jesus. It explains the nature of humans and why humans are so much of a dichotomy. One day doing wonderful, kind, amazing things when a human pulls someone out of a burning building or something, and the other moment doing something that's horrible. And why are we like that? And the Christian message explains it and gives an answer to it. And when I look at all the information that I can glean and say what seems to be the truth about the world I know, based on all this information, I keep coming back to this answer. A good hypothesis doesn't just answer a narrow question. It answers a much broader question. And one of the reasons that I'm a follower of Jesus, because I think his teachings and that message answers a whole bunch of questions that I have about the world around me. Better than any other worldview. Not perfectly, but better than any other worldview.
Yeah, maybe one or two questions,
Okay.
and then.
And I'll stick around all night if you have questions you want to ask me personally.
So I will have the last two questions, and then if you want to stay in the room, you can stay. But if you want to leave, that's fine. So.
Can I leave?
Huh?
No, just kidding. There's a difference.
Not you.
Right. Okay.
Another question about
This is-
the life on Earth or the conditions to have life.
Yeah.
You mentioned a lot that Earth is
Yeah.
created in a certain way. Do you think there are planets out there that haven't evolved enough yet to support life?
Again, you know, if the odds I gave you for a planet like the Earth are the odds based on the best evidence we have. But if there is a God and he took all the possibilities and he still made a planet like the Earth, he could have made many more than one. So there may be a bunch out there. I don't know. What I'm saying is, given what we know that it takes to make a planet like Earth, what's the probability it happened by chance? And the probability it happened by chance seems to be very small. But if you don't do something by chance, then the odds are really good. If you roll a dice, the odds are 1 in 6 that you'll get a 6. But if you put it down, if it's not by chance, you can get a 6 every time. So if there is a God who doesn't need to just go by the chance laws of nature, there could be a whole bunch of planets like the Earth. The odds are that they're not if there is no God, because that's the rolling the dice, that's the chance. So, you know, I don't know one way or another. To me, if we find more planets like the Earth, it's more of an indication there's a God, because the odds are so small that we shouldn't find any like that.
If in the beginning,
Or I'll change the science. Maybe I'm misunderstanding some of the science.
okay. So if in the beginning there was only one tectonic plate, because the continents formed after the flood, survive without earthquakes in God's design?
Yeah, so this is again a question that presupposes a young earth, that everything changed after the flood. In an old earth perspective, where the earth is 4.5 billion years old, that is not the case. So if you ask me the history of tectonic activity on the earth, it's the same as the history that you would find in a natural history museum. Tectonic activity started about 1.5 billion years after the earth was formed. That's when the continents first formed. Before that, the earth was basically water. And 3 billion years ago, tectonic activity started, and there's always been multiple plates. The plates have moved. At one time, the plates above the water were very much next to each other, Pangaea and other supercontinents, and they've continued to move. So the idea that some Christians hold that much of this activity started after the flood described in Genesis, I don't hold to that being true.
So 2 questions. And these are the last ones.
Good.
Okay. So one, what's your story?
Oh man.
You explained a lot about your relationship, but for us.
Yeah, so I'll give a very brief. I actually did grow up in a home where Christian ideas were taught. My dad actually was the pastor of a church, but like almost everyone I know who grew up in a Christian home, particularly someone who asks a lot of questions, I always ask why. I wasn't satisfied with all the answers I was given as a kid. When I was in high school and college, so the age of many of you, I began to ask questions for myself. Are the things I was taught true? Is there evidence for it? Is Christianity true, or is it just another fairy tale? I was taught that Santa brought me presents. I don't believe that anymore. I was taught that if you put a hand on a hot stove, it'll get burnt. I still believe that. So there are certain things I was taught as a child I don't believe, and certain things I do believe. And why do I believe some? Because there's evidence that there's true. So I spent, as a thinking person who was struggling with what is real, what is not real, what was I taught as a child that was real and not real. I probably spent about 10 years between when I was about 16 and mid-20s really working through those questions. And it was that systematic process, some emotional, some intellectual, some willful, some spiritual, where I came to the conclusion that these things are true. When I went into physics as a graduate student, I did some more exploration. I knew that if I was going to be a physicist and study the universe, then I should have some answers about whether or not what I would learn in the universe fit in with my understanding of what I was also taught and believed. And I restudied much of that. And so as an adult, I've been a thoughtful person trying to continually investigate what I believe and why I believe it, and is there evidence for it.
What you still didn't answer the question. You mentioned a lot that your personal relationship with God. But what do you mean by that? Because this concept is very strange for us.
So Christians believe that Jesus rose from the dead. That means he's alive. You can have a relationship with a live person. You can't really have a relationship with a dead person. It's really hard. You can have a relationship with a live person. A relationship with Jesus is different than a relationship with someone else because we don't see him. But God has written us a letter. It's called the Bible. And when you read a letter, you understand a person. We live in a very unique time. You can call someone. I have a cell phone here. My wife can pick it up in Oklahoma and we can talk to each other. That's a rare thing. For centuries, if my wife wanted to talk to me and I was in Romania, she would send me a letter. And the letter would come through the mail, and then I would read it multiple times. I would read in between the lines to see the nuances. And I would look for the little hints that says she loves me because that letter was so special. God has written us a letter. We can read it over and over. We can understand it. That you can have a relationship with someone, we used to call them pen pals back in the old days. You would write letters to people and have real relationships. And then God hears me when I pray to him. So it's a two-way street. I read his letter, he hears me. And then Christians also believe that when you start a relationship with Jesus, when you say, Jesus, I believe you are who you said you were. I believe you are the Son of God who loved me and died for me, and I want to follow you. Then the Bible says that God's Spirit actually comes and lives inside you, and your spirit talks to God's Spirit. Now, I don't totally know how that works, but I have had times in my life when I was talking to God in my mind, and I believe that the thoughts that came in my mind, I say it this way, were both so profound and so unexpected that they weren't from me. They were from somewhere outside of me. They were from God himself. So it's a different kind of relationship, but it's real. I don't know, how many of you, I won't ask the question, rhetorically, how many of you are in a committed relationship? Any committed relationship has ups and downs, has misunderstandings, has communication issues, has good times and bad times. That's the beauty of a relationship with God. It has all of those things, even though it's a different relationship in that it's with someone who you can't see, but who you do communicate with, who communicates with you, and who walks with you, who gives you strength when you need it and peace when you need it. If you talk to anybody who is a Christian who claims that relationship with Jesus, they'll tell you the same thing. It's amazing. I go to Romania, I go to Korea, I go to even France, the French, believe it or not, right? I go to, all over the world, and you talk to people who say they have a relationship with Jesus, and it's the same relationship. It's the same person, the same ideas. It's remarkable. It's because it's real. It's not just in my mind. Is that better?
It's fine.
All right.
It's fine. And now this is the last one, and there are more questions.
Yeah.
Maybe
I will stay. Come talk to me.
You can come after this last question, and you can ask personally the question, or we can do a follow-up sometimes in the future via Zoom or something. And we can
That'd be great. Yeah.
So the last question is, what's your advice? What advice would you give to students in this room in search for truth in a very relative and subjective world?
In a what?
Relative
Yeah.
and subjective world.
Well, again, I think if you want to find truth, you're going to have to explore different options, because no matter what you believe, some of it may be true and some of it may not be. And if you only are, we live in a world, right? If you go to Facebook, it will feed you information that you already believe. It knows that that's how you get clicks and that's how they get money. But if you want the truth, you're going to have to go find information that you don't already believe, because it might be true. And you should take a logic class. There are good arguments and there are bad arguments. Richard Dawkins wrote a book called The God Delusion. I've talked to philosophers. It's got the worst arguments. A sophomore philosophy major could debunk that book and show that it's just totally full of misunderstandings, logical inconsistencies. And a simple logic class would show that. It was a bestseller because it's Richard Dawkins, and he says God doesn't exist, that God's just a delusion. I've read so many books from people I don't agree with. I've tried to read that book a dozen times. It's the only book I can't read because it's so bad.
It's written in Romanian?
Probably. It was, yeah. Anyway, and then I believe ultimate truth, since I am a follower of Jesus, is in Jesus himself. He said, I am the way, the truth, and the life, and no one comes to God except through me. So I believe if you want to find ultimate truth, it's going to be found in the person of Jesus. So I would recommend finding a group like what Eon is head of or works with.
QR code.
What's that?
The QR code.
Yeah, the QR code. Find a group of people who say they know Jesus, that they have a relationship with him, and ask them and do some study for yourself and find out if it's true or not. If Jesus is real and alive, then you can have a relationship with him. It's a cool experiment. You can do it yourself. You don't have to you don't have to go to CERN to do that experiment. You can do it anywhere and see if Jesus is real. Jesus even makes that invitation. He says, come to me and I will show myself to you. Finding truth is challenging. There is fake news. There's a lot of false information out there. And the only way is to learn how to sift through it and learn how to discern for yourself what answers the questions best. And I would encourage you, if anything I've said has resonated with you, I'd encourage you to consider that maybe Jesus and the things he said have truth, are truth. And maybe you can find real peace and real satisfaction and real contentment in Him. That's what I found. That's what many in the room have found. And the cool thing about it for me is goes with what Jesus said. You don't have to give up all the things you love. You don't have to give up thinking. You don't have to give up asking tough questions. If Christianity is true, then you get to ask the toughest questions because there are answers there. And so to me, as a thinking person who always asks why, my wife gets sick of me asking why, you can do that. That's, I don't know, go explore, find out. Find someone who knows Jesus and ask them about what it means.
Thank you, Dr.
Thank you.
Strauss, thank you so much for everything.